In the previous class, we saw about symmetric and asymmetric filters as well as problems on symmetric and asymmetric filters. With the same concept, let us start with the problems how to design and filter using windowing technique. That is, in the previous class, we also saw what are the different types of windows we have. So, that are rectangular window, Bartlett window, triangular window, that is the other name for Bartlett window is triangular window, Hamming window, Hanning window. Those are the 4 windowing techniques which are there in our syllabus. So, with the help of those windows, let us try to design FIR filter. So, the first problem is find HD of n of a FIR filter, FIR low pass filter whose desired frequency response is given by HD of omega, where HD of omega tells what is the desired frequency response, which is equal to e power minus j alpha omega, where the magnitude of omega is less than or equal to omega c, 0 otherwise. So, the length of the filter should be 7, the value of omega c should be 1 radian per sample. So, here what they have done is they have given us the desired frequency response and they are telling us to find out the desired impulse response. HD of n indicates desired impulse response. So, and the data what they have given us HD of omega as well as what is the value of omega c. So, omega c is nothing but the cutoff frequency. So, if we start solving the problem, the formula which is used to find out HD of n, that is the desired impulse response, is equal to 1 by 2 pi integral from minus omega c to plus omega c HD of omega into e power j omega n into d omega. Okay. So, if we look into the frequency response of low pass filter, so this filters allows the range of frequency which is very less, that is which is of lower frequency range. So, if we start finding out HD of n, the value of omega c what they have given is 1. So, let me substitute that, as well as whenever the value of omega is less than or equal to omega c, the value of HD of omega what they have given is e power minus j alpha omega. Let us substitute both the things in this equation, that is, so HD of n will be equal to 1 by 2 pi integral from minus 1 to plus 1. So, what is HD of omega? It is e power minus j alpha omega into e power plus j omega n into d omega. Now, let me write these two exponential terms as a single exponential term. So, if we do so, HD of n will be equal to 1 by 2 pi integral from minus 1 to plus 1 e power, let me take j omega as a common factor. So, the term left out here is n and here the term left out is minus alpha into d omega. Okay. So, let us term this equation as equation star. Now, keeping this equation in mind, let us deal with respect to 2 cases. In case 1, let us assume the value of n is not equal to alpha. In case 2, let us assume the value of n is equal to alpha. So, let us start with case 1. So, in case 1, what is the assumption which we are taking? Let the value of n be not equal to alpha. Okay. If so, the equation of HD of n remains same. So, I will write the same equation. Therefore, HD of n will be equal to 1 divided by 2 pi integral from minus 1 to plus 1 e power j omega n minus alpha into d omega. Okay. Now, I should integrate this exponential term with respect to omega. So, if we integrate, what happens to HD of n? HD of n will be equal to 1 by 2 pi into integration of this exponential term is e power j omega into n minus alpha divided by j into n minus alpha under the limits minus 1 to plus 1. Okay. Now, this entire term is a constant term, so I can move that outside. Yes. Therefore, hd of n is equal to 1 divided by 2j pi into n minus alpha. So, I will write rest of the things as it is, that is e power j omega n minus alpha under the limits minus 1 to plus 1. So, what should I do in the next step? Let me substitute the limits in this exponential term and let us check what is the value of hd of n when n is not equal to alpha. If I substitute the limits, hd of n will be equal to 1 divided by 2j into pi into n minus alpha. So, what is the upper limit? It is 1. If I substitute omega as 1, what is the exponential term which we get? It will be e power j n minus alpha, correct? Minus, and the lower limit is minus 1. If we substitute omega as minus 1, it will be e power minus j n minus alpha. Okay. So, we all know that e power j theta minus e power minus j theta divided by 2j is equal to sin theta. Yes or no? So, we have only the exponential term. If I keep only the exponential term, what is left out? E power j theta minus e power minus j theta will be equal to 2j into sin theta. So, instead of this, can I write it in this form? Yes. And what is theta? It is nothing but n minus alpha. So, if I substitute and write in this form, so therefore, hd of n will be equal to 2j into sine, the value of theta is n minus alpha whole divided by 2j into pi into n minus alpha. So, now if we cancel 2j with 2j, therefore, hd of n will be equal to sine n minus alpha divided by pi into n minus alpha if n is not equal to alpha. If this is the condition, then the desired impulse response for a given FIR filter will be this one. Okay. Now, let us go for second case and let us see what is the expression which we are going to get for hd of n. So, in case 2 what I am taking, let n be equal to alpha in which equation? In equation star. So, first I will write down the equation star. So, that was hd of n which is equal to 1 by 2 pi integral from minus 1 to plus 1 e power j omega n minus alpha into d omega. So, this was our equation star. So, if n is equal to alpha, so alpha minus alpha is 0. So, anything multiplied with 0 is 0. So, it will be exponential to the power of 0. Yes. So, if I rewrite the equation, it is 1 by 2 pi integral from minus 1 to plus 1 e power j omega alpha minus alpha, where alpha minus alpha is 0. So, which leads to exponential to the power of 0. Therefore, the expression will be 1 by 2 pi integral from minus 1 to plus 1 e power 0 into d omega. So, what is e power 0? We know e power 0 is nothing but equal to 1. So, if I rewrite hd of n will be equal to 1 by 2 pi integral from minus 1 to plus 1 into d omega. So, if I differentiate integrate 1 with respect to d omega, that is with respect to omega, if I integrate 1 with respect to omega, so what we are going to get? So, integration of 1 is omega under the limits minus 1 to plus 1. Okay. So, if we substitute the limits, so it will be 1 by 2 pi into upper limit is 1 minus lower limit is minus 1, minus into minus plus, so it becomes 1 by 2 pi 1 plus 1 which is equal to 1 plus 1 is 2, 2 into 1 is 2, so 2 by 2 pi, so I can cancel 2 with 2, therefore hd of n is equal to 1 by pi when the value of n is equal to alpha. So final conclusion is, therefore hd of n will be equal to sine n minus alpha divided by pi into n minus alpha if n is not equal to alpha. So it will be equal to 1 by pi if n is equal to alpha. So this is the desired impulse response for the given desired frequency response of an FIR low pass filter. So since the value of omega was equal to 1, so we got this form. So if we have the standard value of omega, so what will be the equation for hd of n? That will be equal to sine omega c into n minus alpha divided by pi into n minus alpha if n is not equal to alpha. So hd of n will be equal to omega c divided by pi if n is equal to alpha. So that will be the standard equation. Okay. So this is all about the first problem. So now let us move on to the second problem and let us try to find out the desired impulse response using different windows, and with the help of those windows let us try to find out what is the impulse response of the filter. The second problem which we are going to solve is a low pass filter is to be designed with the following desired frequency response hd of e power j omega which is equal to e power minus j 2 omega, where omega is less than or equal to pi by 4 and it will be 0 for rest of the condition. So determine the filter coefficient hd of n and impulse response h of n. We need to find out two quantities, this and this. If omega n is a rectangular window, so they are telling us to use rectangular window for the purpose of designing an FIR filter, which is defined as omega r of n which is equal to 1, where the range of small n is from 0 to 4 and it will be 0 in rest of the condition. So find the frequency response of the resulting filter. So that is, they are telling us to find out three quantities. The first quantity is hd of n, the second quantity is h of n, and finally it is h of omega, that is the frequency response. So whenever the question is direct like design an FIR filter, it is nothing but you need to find out all this parameter. Here what they have done is they have indicated all the parameters to be found. Okay, but in few questions what they do is they just give design an FIR low pass filter for the given frequency response and they give hd of omega. Okay, and they tell which type of window to be used. So based on that we need to simplify. Here they have told you need to find out all the parameters. Okay, so if it is only design or if it is specifying all the parameters, it is one or the same. Okay, so what I have done is I have written the general equation for desired frequency response. Now if I compare this with the given desired frequency response, the exponential term is e power minus j 2 omega. So here it is e power minus j alpha omega. So if I compare these two exponential terms, so one thing what I can say is the value of alpha is equal to 2, correct? Similarly, if I consider the range term of the standard equation with that of the given question, so the value of omega c is equal to pi by 4. So now let me try to find out the value of m. So we know alpha is equal to m minus 1 by 2 from the phase characteristics. So what is alpha? Alpha is 2. So 2 is equal to m minus 1 by 2. If I simplify this, it is 4 which is equal to m minus 1. Therefore the value of m is equal to 5, which is an odd number. Okay. Now let us try to find out hd of n first. Then let us move on to h of n. So we all know the general equation for hd of n is equal to 1 by 2 pi integral from, I will substitute the limit. Here the range of omega c is pi by 4. So, the limits will be minus pi by 4 to plus pi by 4 and hd of omega into e power j omega n into d omega, or you can just write it as from minus omega c to plus omega c and you can substitute the limits later. So, I have written the limits directly. Now, so what is the thing what they have given? They have told us the value of hd of omega is equal to e power minus j 2 omega. So, let us substitute it here. Therefore, hd of n will be equal to 1 by 2 pi integral from minus pi by 4 to plus pi by 4 e power minus j 2 omega into e power j omega n into d omega, correct. So, now instead of two exponential term, let us combine and write it with a single exponential term. So, the value of hd of n will be equal to 1 by 2 pi integral from minus pi by 4 to plus pi by 4 e power j omega into n minus 2 into d omega. So, let us term this as equation star. Okay. Now, we got the standard equation for hd of n. Now, what I need to do? I need to deal with respect to two cases, that is when n is equal to alpha, when n is not equal to alpha. We know the value of alpha also, the value of alpha is 2. So, let us start with case 1 and let us see what is the expression which we are going to get for hd of n. Case 1. So, in case 1, let the value of n be not equal to alpha. In which equation? In equation star. So, the equation remains as it is. So, let me rewrite the equation again. So, hd of n which is equal to 1 by 2 pi integral from minus pi by 4 to plus pi by 4 e power j omega n minus 2 into d omega. Now, what we need to do? We need to integrate the exponential term. Yes. So, if we integrate it, so 1 by 2 is kept outside. So, integration of e power j omega n minus 2 is e power j omega n minus 2 divided by j into n minus 2, where the limits is from minus pi by 4 to plus pi by 4. So, minus pi by 4 to plus pi by 4. Okay. So, let me take this as a common factor outside. So, I can write it as 1 divided by 2j pi into n minus 2. So, if I substitute the limits for this, so it will be equal to e power j pi by 4 into n minus 2 minus e power minus j pi by 4 into n minus 2. Again, this is in the form of e power j theta minus e power minus j theta. I can write it as 2j sin theta. So, if I write this in the form of sine, I can write it as 2j into sine. The value of theta is pi by 4 into n minus 2. So, whole divided by 2j pi n minus 2. Clear? So, now I can cancel 2j and 2j. So, what is left out? It is nothing but sine pi by 4 n minus 2 whole divided by pi into n minus 2. So, this is the expression of hd of n when the value of n is not equal to alpha, that is when it is not equal to 2. So, let us move on to second case and let us see what is the expression for nd of n when hd of n when the value of n is equal to 2. Starting with case 2. So, in case 2, let n be equal to alpha which is equal to 2, in which equation? In equation star. If this happens, hd of n will be equal to 1 by 2 pi integral from minus pi by 4 to plus pi by 4 e power 0 So it is n minus 2. So this is your equation star. If this is equal to 2, 2 minus 2 is 0. E power 0 is nothing but equal to 1. So I have written it as e power 0 into d omega, which can be written as 1 by 2 pi integral from minus pi by 4 to plus pi by 4, 1 into d omega, correct. So what is the integration of 1? So it is nothing but omega. So 1 by 2 pi omega from pi by 4 to minus pi by 4. So if I substitute the limit, so this will be equal to 1 by 2 pi by 4, minus of minus becomes plus pi by 4, which is equal to, the LCM is 4. So if I add the numerator part, it will be 2 pi divided by 2 pi into 4. 2 pi gets cancelled. Therefore, the value of HD of n when n is equal to alpha is nothing but equal to 1 by 4. So now let us summarize what we did now. Therefore, HD of n will be equal to, so when it is not equal to n, this is the expression, that is sine pi by 4 n minus 2 whole divided by pi into n minus 2 when the value of n is not equal to alpha. When it is equal to alpha, the value is 1 by 4. So this is the first thing, that is we found out HD of n. So the first part is done. Now we should move on to the second part, that is we should try to find out h of n. To find out h of n, we know the standard formula, h of n, which is nothing but equal to HD of n into omega of n, correct? So but which type of window they are telling us to use? They are telling us to use rectangular window. So this becomes omega r of n. So if I write this formula in a simpler way, so what I can do? So the first parameter is n. So let the second parameter be HD of n. Let the third parameter be omega r of n. And the final parameter is h of n, which is equal to HD of n into omega r of n. So this is a simple table with the help of which we can find out h of n. Okay. Now what was the value of m which we got? The value of m which we got was 5 in the beginning. If m is 5, we know small n ranges from 0 to m minus 1, which is nothing but from 0 to 4. So the range of n is 0, 1, 2, 3 and 4. Now we need to find out the value of HD of n. In order to do so, the first value of n which I am going to give is 0. In which expression? In this expression. So that gives us HD of 0, which is equal to, so if I substitute 0 here, it becomes sine minus 2 pi by 4 divided by minus 2 pi. So I need to find out what is the value. Whenever you try to find out this kind of problems, that is design of filter problems, kindly keep your calculator in radians mode. In order to find out h of n, we created this table, have substituted the value of n as 0 in which expression? In this expression. So what happens to this term? So if we simplify by keeping the calculator in radians mode, HD of 0 will be equal to 0.1592. Similarly, if the value of n is equal to 1, HD of 1 will be equal to 0.2251. So what you need to do? Again come here, substitute the value of n as 1. So what will be the equation? It will be sine pi by 4, 1 minus 2. That is, it becomes minus 1 divided by pi 1 minus 2. So if we simplify this, it is going to give this particular data. So if n is equal to 2, what is the value which we are getting? So we know the alpha value is 2. So here only we are getting the value of n as 2. So when n is equal to 2, what is the value of HD of 2 equal to? It is equal to 1 by 4. 1 by 4 is nothing but equal to 0.25. Similarly, substitute the values of 3 and 4 in that equation, gives us these two values. Okay. The second column is WR of n. So what they have done, they are telling us the rectangular window is defined as this particular expression, and what is the value of omega r of n from 0 to 4? For all the values it is equal to 1. So for n 0 it is equal to 1, when n is 1 it is equal to 1, when n is 2 it is equal to 1, when n is 3 it is equal to 1, when n is 4 it is equal to 1. Now I should find out h of n. Okay. So what is the formula? It is nothing but hd of n into omega r of n. It is nothing but multiplication of these two corresponding elements. So if I multiply these two, it gives us 0.592. Similarly, multiplying these two gives us 0.2251. Again, multiplying these two gives us 0.25. Multiplying these two gives 0.2251. And finally, multiplying these two gives us 0.1592. So what we did? We completed the second question also. They told us to find out h of n. We found out h of n. So if I tabulate that, h of n will be equal to 0.1592, 0.2251, 0.25, 0.2251, and finally it is 0.1592. Okay. Now the last part of the question is to find out the frequency response. In order to find out the frequency response, we should know whether the value of m is even or odd, and we should know whether it is symmetric and antisymmetric condition. For that, we know the value of m which we calculated in the beginning of this problem, and it was equal to 5, and we know 5 is nothing but an odd number. So I can conclude therefore m is odd. Okay. How to conclude the symmetric part? So if we look into the sequence of h of n, so this is the center point. So this is symmetric to this, this is symmetric to this. That is, if I fold at 0.25, that is when n is equal to 2, the value of n is equal to 1 is matching the value of n is equal to 3, the value of n is equal to 0 is matching the value of n is equal to 4. Therefore it is symmetric. So the condition is m is odd and symmetric. Is this clear? So whenever it is odd and symmetric, what is the expression for h of omega which we saw in the derivation of symmetric and antisymmetric filter? So the equation for h of omega will be equal to h of m minus 1 by 2 plus 2 into summation n ranges from 0 to m minus 3 by 2 into h of n into cos m minus 1 by 2 minus n into e power minus j m minus 1 by 2 omega. So this is the standard equation when the value of m is odd and symmetric. Now to this we need to substitute the value of m and we need to substitute the value of h of n, and we can find out what is h of omega. So I have written the equation. Now let me substitute the value of m. We know the value of m is equal to 5. So therefore h of omega will be equal to, if m is equal to 5, 5 minus 1 is 4, 4 by 2 is 2, h of 2 plus 2 into summation n ranges from 0 to, the value of m is 5, 5 minus 3 is 2, 2 by 2 is 1, 1 h of n into cos, so here I have missed omega, so omega into, again the value of m is 5, 5 minus 1 is 4, 4 by 2 is 2, 2 minus n into e power minus j, m minus 1 is 4, 4 by 2 is 2, so which is equal to 2 omega. Okay. Now what let us do is, let us expand the summation and let us see what we are going to get. So if I expand the summation, h of omega will be equal to h of 2 plus 2 into h of 0 into cos omega. 2 minus 0 is 2. So 2 into omega is 2 omega. So let me write it directly. So what I did, I substituted the value of n as 0. So I wrote it as h of 0. Here if the value of n is 0, 2 minus 0 is 2. 2 into omega is 2 omega. So I wrote that directly. Plus the next value is h of 1 into cos. 2 minus 1 is 1. 1 into omega is omega into e power minus j 2 omega. Okay. So now let me multiply this 2 inside the bracket. So if I multiply that inside the bracket and if I arrange with respect to the indexing, so the first will be 2 into h of 0 cos 2 omega plus 2 into h of 1 into cos omega plus h of 2 into e power minus j 2 omega. So now what I need to do, I know the value of h of 0, h of 1 and h of 2, so which is already calculated. So let us substitute in this particular expression. If we substitute the values of h of n, so the expression will be 2 into 0.1592 into cos 2 omega plus 2 into 0.2251 into cos omega plus 0.25 into e power minus j 2 omega. So in the next step what I can do, I can multiply these terms which gives us h of omega. After multiplying these terms, so h of omega will be equal to 0.3184 cos 2 omega plus 0.4502 cos omega plus 0.25 into e power minus j 2 omega. So this is how we can find out the frequency response of a filter using any type of window. In this problem, they are insisting us to use rectangular window. Okay. So first what I need to do, I need to find out HD of n. Whenever it is problem related to designing of an FIR filter, they give the desired frequency response. The first step is to find out HD of n. Then we need to find out impulse response by drawing the table which I had shown few minutes before. Later we need to check whether the condition of m is even or odd and whether it is symmetric or antisymmetric. Based on those conditions, write down the equation, standard equation of h of omega, then substitute the values which we have calculated, which finally gives the frequency response for this desired frequency response of an FIR filter. So this is how we can design an FIR filter using rectangular window. In upcoming classes, let us see how to design an FIR filter using other windows which we have in our syllabus. Thank you for today's session.